When it comes to aircraft noses across all types of aircraft, there can be very noticeable differences. Some aircraft, like Concorde, featured long, pointed noses, while passenger airlines such as the super popular Airbus A320 often feature more rounded noses. So in this video, we take a look at why Airbus and Boeing aircraft have such different nose shapes, how aerodynamics influence their designs, why Boeing's newest aircraft are moving away from its traditional look, and what is actually hidden inside the nose of every modern jetliner. One of the easiest ways to tell whether a passenger jetliner is an Airbus or Boeing aircraft is by looking closely at the shape of its nose. On the whole, Airbus aircraft feature a rounder, more bubble-like nose, with a smoother curve from the top to the bottom of the plane. The cockpit windows will also tend to be more rectangular, having a straight cut. Good examples are the A320, A330, A340, A350 and A380. As for Boeing aircraft, they tend to have a sharper, longer and pointier nose with a more elongated beak-like look. The cockpit windows will also be more aggressively slanted with a more angular look to the panes. Good examples of aircraft with a typical Boeing nose are the 737, 747, 757, 767 and 777. Using the shape of noses seen in the animal kingdom to provide a comparison, Airbus noses tend to look like those of a stubby dolphin, while Boeing noses tend to look like a bird's beak. At first glance, the longer and sharper noses of Boeing aircraft may imply that they have better aerodynamic qualities, but whether this is true is actually a fairly complicated question. Are pointier noses more aerodynamic? The answer is that it depends on how fast the aircraft is going. An aircraft's performance in the air is dependent on the whole shape of the plane, but the nose is an important factor, as it is the first part of the plane to contact oncoming air. When going at subsonic speeds, the nose of the aircraft creates a rumor in the air in front of it, and so air molecules will start to push each other out of the way of the oncoming plane before coming into contact with it. When the nose of a plane is traveling at supersonic speeds, however, the air molecules will not have time to push each other out of the way, creating what is called wave drag. Therefore, it is advantageous for the nose of a supersonic plane, such as Concorde or military jet fighters, to be pointed to help reduce the effect of resistance from smashing into the air. Passenger aircraft which normally travel at around Mach 0.85 need not worry about wave drag, so the rounder nose is more aerodynamic given the relative size of the rest of the plane. While the mechanics of sonic booms are a little more in-depth, the sound is basically caused by the air compressing and exploding, like the snapping back of an elastic band, and it can happen in a prolonged manner as an aircraft travels, which is one of the reasons that Concorde was banned from flying in many countries. As for why Boeing and Airbus have distinctive nose shapes, the history of the two manufacturers played a large part in how they came to be. Boeing was founded in July 1916, and since their first airliner, the Boeing Model 247, the manufacturer has continued to make jetliner noses with a similar general shape. Using wind tunnels, which came into use towards the end of the 1800s, the manufacturer tweaked the design to make it more aerodynamic over time. From then on, Boeing invested in equipment for making similar nose shapes and also employed engineers and designers accustomed to creating them, and so it became much more practical to keep creating something similar to what they'd done in the past. A conversation on Aviation Stack Exchange highlights the fact that the corporate culture and history part is that Boeing has always built their noses that way, and senior engineers have a tendency to return to designs they've used successfully before. If you look at the nose of a 747 and the nose of a B-17, you'll see some distinctive similarities that follow through all the major Boeing aircraft. Another thing to consider is Boeing's visual brand identity, and the nose has become an identifiable Boeing feature over time. The aforementioned Aviation Stack Exchange contributor adds that, disgruntled Boeing engineers told me once that they spent 3 months optimizing the tailplane fuselage intersection of the Boeing 767, only to have their design rejected by upper management because it looked too much like McDonnell Douglas. Yes, the outside shape is important to management to express their brand. Airbus was formed in 1970 as Airbus Industrie GIE, a consortium of European aerospace companies. By this time, designers had the benefit of computer modelling, so they could determine the most efficient airliner nose shape before even taking mock-ups to the wind tunnel. The result was the short, rounded, dolphin-like shape we see today. Technically, the Airbus nose may be slightly more aerodynamic, as its decreased length could result in less skin drag. As if confirming that the classic Boeing nose shape was aerodynamically inferior to other options, Boeing designed the 787 Dreamliner with a nose that resembles a sleek, droopy cone, doing away with the more upright windshield and elongated nose. The design is remarkably similar to the first jetliner ever built, the de Havilland Comet, which was first delivered in 1952. The 787 is a clean-sheet design that was first delivered in 2011. It was created with a strong focus on efficiency, and around 80% of its components are made of lightweight composite materials. It is interesting to see airliner nose design coming full circle by returning to a comet-like shape, as the upcoming super-efficient Boeing 777X also shares the cone-like design, indicating that Boeing intends to keep utilizing this nose shape in the future, finally moving away from its prior visual identity. The 787 is also visually distinct thanks to other aspects like its four-window cockpit, raked wingtips, and noise-reducing chevrons on its engine nacelles. All of these design changes paid off, as Boeing was able to boost an estimated fuel efficiency improvement of 20% compared to older aircraft like the Boeing 767. Being able to carry over 250 passengers over long distances helped the 787 to break up the hub-and-spoke aviation model, opening up more flexible point-to-point route planning for airlines. There are some constraints to the shape of a jetliner's nose, but the bulbous dome seen on Airbus planes is ideal for housing the radar systems, a vital component for navigating in the skies and avoiding collision. For example, the A380 aircraft's body is covered in various sensors, and the radar is positioned in the nose. As is the case with most airliners, the radar system is unique in that the antenna within needs a good deal of space to rotate. The typical jetliner nose, therefore, is also a radome and is constructed of a material through which radio waves can pass easily. Inside, the antenna is protected from the weather and the rare collision with objects like large hailstones and unfortunate birds. There is a great deal of thought, design, and testing that goes into Boeing and Airbus jetliner noses. Further to the nose's function of housing the radar, it must also be optimized in shape for aerodynamic performance, and suitable materials must be chosen to allow the radar to function optimally. The overall shape of the nose must also be in line with the manufacturer's visual identity and must also be aesthetically pleasing. With all of this, it is a tall order for manufacturers, and the field is always developing. What do you think? Do you prefer Airbus's rounded nose or Boeing's traditional pointed design? And do you think Boeing made the right move by adopting a more Airbus-like shape on the 787 and 777X? Let us know by leaving a comment, and don't forget to subscribe for more aviation content. See you next time. And be sure to check out Simpleflying's flight tracker. From live alerts and data on commercial, military, and government flights, it goes way beyond your standard tracker. It was built specifically for avgeeks, free and live, right at your fingertips. In addition to our daily YouTube videos, Simpleflying publishes over 150 articles and a podcast every week. Visit simpleflying.com.